This video is going to go over hydraulic pumps and PTOs for a logging truck or a grapple truck. I'm familiar with some gear pumps, the P350, P450, and the F2 piston pump by Parker. There's definitely other pumps out there, and get with your builder and decide what they want to use, what they're familiar with. Typically, gear pumps last longer than piston pumps, but they do generate a little bit more heat, and they will kind of lose some flow over time. First, I want to touch on the loader that I'm using and what it requires. It needs 3,410 psi. Sometimes it'll spike, a couple percent over that or whatever. But that's the base, and then it's 2 by 21 gallons per minute. So I want to find out how much horsepower it's going to take to actually drive that pump and what the PTO is going to come in at. So here's a website that's got some math on it to find out what your pump needs. So I'm going to take 42 gallons per minute times 3410 psi divided by 1714 equals 83.5, so call it 84 horsepower. That's a max effort. If it was like a blower mulch truck, it would be using that all the time. But for a gravel truck, you might be using 60, 70 horsepower sometimes, depending on how much you're using all the functions. But it's just a rough idea of what it requires. We'll roll over to Fuller real quick. If you're using the Eaton transmission, it's a good idea to check to see if it has the upgraded input shaft bearing so that it can handle higher torque loads. So you get with your transmission manufacturer and have them run your serial number and transmission type and see if they can check it out for you. If not, you'll need to upgrade it. This is the Muncie website. I've already plugged in an Eaton 18-speed. In my case, I'm using a 2219B. It comes with the heavy-duty input shaft bearing from the factory. A couple different choices here. This one is 52% engine percentage. That means basically if you turn 1,000, it would turn the pump 500 RPM, somewhere around there. So depending on what size pump you're using, you have to get this percentage in line with where you want to run the engine and go from there. Typically gear pumps take a little bit more shaft speed to make the gallons per minute than big piston pumps. So if you'll notice, as the engine percentage goes up, the torque and horsepower go down. So you want to kind of make sure that you spec your PTO out correctly. If you go too light, it might have a shorter lifespan or break parts eventually. Or if you go too heavy, you'll have to turn the engine RPM higher to get to your shaft speed. So we'll talk about F2 7070 because that's what I end up using. It's a very robust pump. It can go to 5,000 psi, where most gear pumps are 3,500, 4,500 or so. We may put a larger loader on this truck at some point, so I wanted to have a little bit more pump and PTO than I needed in case we go that route. This is liters per minute, so you'll just need to do the math to convert to gallons per minute, and then get your pump shaft speed to where it needs to be based on what you're using. In my case, 1136 RPM is just over 21 gallons per minute. So piston pumps usually rated 95 to 98% efficiency. So I'm going to turn a little bit faster than that, probably about 1189 shaft speed. So I'll have a little bit more flow, and I've got enough cooling capacity that it won't really matter. So I'll roll back over here to this is the F2 piston pump. You can also rotate the case for different mounting situations. It's been out for a while. They've upgraded it. It's very robust. They use a lot overseas. Those loaders are very fast, and I think they're onto something. So I want a little bit more performance. Downside is it costs more, and when it's time to replace it, you just have to replace it. You can't rebuild it. So here's a couple of different flow numbers. It's in bar. You can convert that to PSI. I think that's around 5,000. But this is what I end up using. And I guess the only other thing I have to say is with any hydraulic system, you want to make sure you have enough cooling. I personally like to keep the hydraulic oil around 100 to 110 degrees for performance. I've noticed personally that as the oil heats up, over 130, 140, you lose a little bit of lifting capacity. Um, and my rule of thumb is anything over 175 degrees, I'll go ahead and shut the machine down, because if you continue and it gets hotter, you can cook a lot of the seals out, and it's just not a good thing. But I went with a larger cooler on this particular truck because we are in a very hot climate, and I just wanted to make sure I'm on top of any heat that can be produced, and I wanted the most power out of the loader as possible. So that about does it.